Yeah, this question is a little tricky because the tension force on the rope is no more than 90 degrees. And you see that in previous ones we'd have a beam with a tension that's a straight to the left or straight to the right, or we might have a beam, like we can see there's a lot more 90-degree angles. But in this one we have this angled beam plus this angled rope. So the hard part is just being able to recognize what is the perpendicular distance, or what is that perpendicular force. So let's draw our forces acting on this first. So we have this force downwards in red. We have a force center of mass right in the middle. Let's call this force just F. We'll call this one force center of gravity. And we have this force acting along this rope. And we'll call that T. So let's look at each one separately. So we first look at, let's just look at this force at the far right. So I say, what is the torque caused by that force? The torque caused by that 45 kilogram mass. So torque is equal to force times distance. Again, we need to find that perpendicular value. So we say, okay, torque is equal to, what is that force? The force is 45 kilograms multiplied by 9.81 meters per second squared. And we need to find out the distance part now. You say the metal pole is 2.4 meters long. So I can write out 2.4 meters. But I'm not quite done, because again, that distance is from here to here. Right now, this line that I just drew is not perpendicular to F. So I need to find the perpendicular component. So how I'm going to do that, I'm going to draw an angle. So because I know it's 70 degrees and this other angle is 20 degrees. So we need to find out this distance, just the distance from here to here. Because that distance, that's this blue line I'm drawing, is the perpendicular distance to that force. So what is that distance? If the slanted arm is 2.4 meters, if I multiply this by cos 20 degrees, I will have the perpendicular distance from the pivot. So cos 20 degrees. So this is the torque caused by that force on the far right. Since I found that one, finding the force center of gravity is pretty straightforward. So torque center of gravity, this is equal to, what's the mass? The mass of the pole itself is 5 kilograms. You can see right here, 5.0 kilograms. Multiplied by 9.81 meters per second squared. And it is halfway along the pole, so 1.2 meters. And it's dealing with the same trig, so it's multiplied by cos 20 degrees. This next one is tricky. So we have to kind of orient or rotate our mind. So we have this tension T up in an angle. So we're going to form a right angle triangle with the pivot. So I'm going to draw it like so. Okay. So that blue line I just drew, that dotted blue line, is the perpendicular distance from the pivot to the force. Okay. The perpendicular distance from the pivot to the force. So we need to find out what is that angle. That is opposite the 50. So you see it's sine 50. So I'm going to write out. So we have the torque of that tension. Okay, so you're saying the force is T. That's what we're trying to solve for. And the question is, how many meters from the pivot is it? That's connected at a point 1.6 meters from the pivot. So you're going to have 1.6 meters. But again, I need to find that perpendicular distance. So I'm going to multiply that by sine 50. degrees. Now we're pretty much done. We just set up our equation. We know that the sum of the torques must equal to 0. So in this case, the counterclockwise must equal to clockwise. I'm going to write down T 1.6 meters sine 50 degrees is equal to 45 kilograms times 9.81 meters per second squared, multiplied by 2.4 meters cos 20, plus 5.0 kilograms multiplied by 9.81 meters per second squared, multiplied by 1.2 meters cos 20 degrees. And as you get better at this, you can just go straight ahead to writing this one single big expression, and we can just solve for our tension. So you plug it all in, we end up with a value of 860 newtons of force.